All right, good morning everyone. Hope your day is going well so far. So today we'll talk about summation notation as well as arithmetic series. And for the do now, I want you to recall, if you remember what this notation means in algebra 2, um, then please, solve these two questions. So here we have the summation of k squared from 1 to 5, and here we have the summation of 1 over j from 3 to 5. Okay, so we'll give you just like 30 seconds to solve this. These should be quick, and then we'll talk about the solution. Okay, I'm going to scroll up for the solution. So for the first one, a bit. Okay, for the first one, if you remember, right, we're going to plug in 1 to 5 into k squared and then add it together. So we have 1 squared plus 2 squared, then 3 squared, 4 squared plus 5 squared. Add those all together, we're going to get 55. Okay. For part B, do the same thing, but here we're going to start at 3. So we're going to 3, 4, 5, plug in into this variable, j. So we get 1 over 3 plus 1 over 4 plus 1 over 5. For this, I didn't show the, I guess the adjustment for the denominators, but it's going to come out to 47 over 60. So that would be like 20 over 60 plus 15 over 60 plus 12 over 60. But yeah, you're going to get 47 over 60 for part B. Now, if you didn't remember this notation, right, we're going to go through it again today, but that was just like a warm-up to what we're about to solve in this lesson. Okay. And yeah, while you finish copying this, let me have you think back to coding. So if you remember your coding for all class, if you took that class, this is exactly like a for loop, right? So a for loop runs some operation, some function from one number to an ending number, right? So in this case, it's like 3 to 5. Over here, it's 1 to 5. And then we're going to run that to k squared. I guess the only difference here is that in each of these cases, we're going to add them, right? But for the for loop encoding, right, you don't necessarily have to add all of them. But yeah, this is exactly like the same type of mechanics, right? Just running from 1 to 5 for some formula. Right? Okay, does anyone still need the do now solution? Okay, if not, then I'm going to scroll down. So let me give you an overview of the rest of the lesson. We're going to define summation notation, then some examples, and then we're also going to talk about arithmetic sequences. We're just going to define that, and then after that, it's just the classwork. Okay, so pretty quick lesson. Okay, so here it is. All right, here's summation. Can I get a volunteer to read this, please? All right, go to Leo.
Summation definition: given a sequence A1, A2, A3, A4, and onwards, we can write the sum of the first n terms using summation notation or sigma notation.
Okay, thank you for that. Yeah, so is exactly as we did in the do now. Now, note that here, you don't necessarily have to start at 1, right, as we saw in the do now part B, right? You can start at 3, for example. But conventionally, normally we start at 1. And yeah, we just add each of the numbers that you get after plugging in each index, so like 1 to n, into whatever this formula is. Okay. Right, so like for part A in the do now, it was like you square the number, and then for part B in the do now, it was like the reciprocal of the number. Okay. But, this should remind you of something from yesterday. Does anyone remember what this looks like? So like you're adding A1 to AN, right? That was like one of the topics from yesterday. All right, see an answer in the chat. Well, partial sums, right? Partial sums, yeah. So, yeah, partial fractions, that was like the thing we did maybe like 2 months ago. But yeah, partial sums. Very good, very good. Yeah, so like here, it would be like the partial sum from 1 to n, right? And the do now, like I think with part A, we did the 5th partial sum of that sequence, right? Because like we had the first 5 terms, right? 1 to 5. Okay, but yeah, does anyone still need this definition here? Okay, if not, I'll move on. So next is some examples. We're going to find each sum. I'm going to scroll up for the solution, but here are the 2 questions. Okay, so for this example, right, part A, we're going to find the sum from 5 to 10 of I. And then for part B, we're going to find the sum from 1 to 6 of 2. Okay, so here we just plug in 5, 6, 7, 8, 9, 10, add them all together, we're going to get 45. Okay. For part B, this might seem confusing since there's no variable, but since it's just a constant, all we have to do is just add 2 for each index here. So we're going to run this for 1, 2, 3, 4, 5, 6. So like 6 times. So we'll add 2 to itself 6 times. So 2 plus 2 plus 2 plus 2 plus 2 plus 2 is, it's going to be 12. Okay. All right, so part A, 45, part B is 12. Okay, so, conceptually speaking, this is not like a difficult concept. It's just a matter of getting used to the notation, right? So, mathematicians, rather than like having to write 5 to 10, right, they can just write this, right, which is quicker. Or like, it would save time if you go through a larger range, right? 5 to 10 actually might be, pretty quick to write, but if you're writing like 1 to 1,000, right, you don't want to write that. So rather than doing that, you just write this, use this summation notation. Okay, does anyone still need this example here? Okay, if not then, next we have this example. We're going to write this sum. So here we have a sum. It's like reverse. We have a sum, and we're going to convert it back to sigma notation. So as you can see, it's like 1 cubed plus 2 cubed all the way to 7 cubed. and we add them all together. So as you see, right, it's going to be something cubed, right? And then the indices, right, the numbers that we plug in, it's going to be 1 to 7. So here we can write this as the sum of k cubed from 1 to 7. Okay. Yeah, that's all it is. The variable, you can change that. It doesn't have to be k. It could be something else. But yeah, I decided to use k. So yeah, k cubed, sum of k cubed from 1 to 7. Okay, while you finish copying that, next we're going to see this definition of arithmetic sequence, which you also might remember from Algebra 2. But yeah, can someone read this, please? All right, we'll go to Sonny.
Arithmetic sequences. Definition. An arithmetic sequence is a sequence of the form a plus d, a plus 2d, a plus 3d, a plus 4d, and so on. The number a is the first term and d is the common difference of the sequence. The nth term is an arithmetic sequence is given by a sub n equals a plus n minus 1 d times d.
Okay, thank you for that. Yeah, so arithmetic sequence is just a sequence that where you just add some common number to each successive number. But yeah, we're going to use this formula a lot, like a sub n equals a plus n minus 1d. You're going to see it in homework, especially. But yeah, the reason why it's n minus 1 is because, at least conventionally in our textbook, right, we start with a sub 1 rather than a sub 0. Right, so for that, like for example, like a sub 2, the second term in an arithmetic sequence, we want to just add one of the common differences. So let's say we have the arithmetic sequence of 1, 3, 5, right? Keep it simple. A sub 2 here, the second term, is 3. Right, so a sub 2 is equal to 1 plus 1 times 2. Okay, so we just added one of the 2's to get to 3. Right, and for 5, we added 2 of the 2's to get to 5. So we do, but this is a3, so we do 3 minus 1. Now, if you start with a0, right, as our textbook does not do, right, you could see this as a plus n times d. Right, so this would be a1 now, right, and the first number would be 1 plus 1 times 2. That's 3. So yeah, again, the n minus 1 comes from just the fact that we start at a sub 1, not a sub 0. Okay, so you have to subtract 1 from the index. Okay, does anyone still need either of these? Okay, if not, then I'm going to move on to the classwork, which is actually the homework. So again, the homework is to just complete the classwork. Okay, so here's question 1. Just 3 questions actually, so here they are. But yeah, here's question 1. So write the sum using sigma notation. So we have a sequence, or rather a sum, partial sum I should say, and we're going to write this using sigma notation. Okay. So as you can see, right, what we're doing to each number is just taking the square root of each, and we're going from 3 to 77. Okay, so whereas the formula is going to be square root of k, and then we're going to go from k equals 3 all the way to 77. So yeah, this is like the same exact thinking that would go into writing a for loop in computer science and like coding, right? So you're just like, you have a formula that you have in mind, or like a sum, for example, and you want to write, you need to identify the indices, right? The starting index and the ending index, and then the formula for it. In this case, square root of k. Is anyone thinking of going to computer science? All right, about half of you. No one? Oof. I'm surprised. Okay. I'll go on to question 2 then. For question 2, we have found the first 6 terms and the 300th term of this arithmetic sequence. So yeah, we have an arithmetic sequence, right? And the common difference here, right, the number that we're adding to each number to get the next number is -6. Right, so it doesn't always have to be increasing. It could be a decreasing arithmetic sequence, as we have here. So we have -6, right, is the common difference. And then just to get an idea of like what the rest of the sequence looks like, or the first 6 terms rather, we're just going to add -6 to each number. So we go from 7 to 1, then 1 to -5, then -5 to -11, then -11 to -17. Okay, so these are the first 6 terms, and I'll label this as an answer. And then they also want to find the 300th term. So if you remember the formula, right, we take a sub n is equal to a, so we'll write a sub 1, the first number, times that plus n minus 1 times d. Okay, so in this case, let me get rid of this. A of 300 is going to be 13, which is the first number, plus 299, right, which is 300 minus 1, times -6, and if you calculate that, you're going to get -1781. Okay, does anyone still need question 2? Alright, so I'm going to go on to question 3 then. Question 3, let me change this. Question 3, here we have the 11th term of an arithmetic sequence is 52, and the 19th term is 92, and they want us to find the 1000th term. Okay, so we're going to use the formula that we had right here, same formula. A sub 11 equals a plus 11 minus 1 times d, and then that equals a plus 10d, right? So, we don't know what the first term is, and we don't know what the common difference is. So we have two variables that we have to solve for. Okay, luckily we have two equations, right? Because the other equation is going to come from the 19th term, being 92. So a sub 19 is equal to a plus 19 minus 1 times d. So that's a plus 18d. And again, we're given that a sub 11 is 52 and a of 19 is 52. 92. That's a typo. But yeah, so we get two equations, right? A sub 11 is a plus 10d, and that equals 52. And then 92, the 19th term, is equal to a plus 18d. Okay, and then from here we have two equations. We can solve for the two variables. We're going to subtract the two equations. So I actually did this equation minus this equation. And then if you do that, you're going to get 8d is equal to 40. Right, so like 92 minus 52 is 40, and then 18d minus 10d is 8d. Okay, so 8d is 40, which means dividing both sides by 8, you get d is 5. Okay, from there you can solve for a. So you can use either of the two equations. I use the first one. 52 equals a plus 10 times d, which is 5. And then 52 equals a plus 50. Subtracting 50 from both sides, you get a is 2. So therefore, the first number in the arithmetic sequence is 2. The common difference is 5. Okay, from there we can solve for the 1000th term. So just remember that we have to solve for this. But yeah, a sub n is going to equal 2 plus 5 times n minus 1. From there we can plug in 1000. For n, we get a of 1000 is equal to 2 plus 5 times 999, and that will yield 4,997. That's our answer. Okay. All right, so yeah, all of you are done with the homework. If you copy this, right, these are the 3 solutions to the classwork, which again is also the homework. Okay. All right, so let me close with announcements. 2 things. One, there's SGI today, per usual. 2:47. Secondly, reminder that our next and last quiz is this Friday, so please check Google Classroom for the topics list. Other than that, I'll close here, so you're free to go, and I'll see you all tomorrow. All right, have a great day and take care.
Thank you.
All right, you're welcome.
Thank you.
All right, you're welcome.